Okay, so in this video we're going to look at absolute value inequalities. Now, as we've seen with our section on inequalities, we can have one of two situations, right? We can have absolute value of x less than or really equal to. We see that equal to, all that really does is, all that is signifying is, does it include the endpoints or not? So there's really two situations to look out for. Right, with or without the less than will not affect the approach to it. Right? Now, how do we solve something like this, right? So let's take a look, or let's replace a with some number, right? Let's take a look. Let's say we say absolute value of x is less than or equal to 2. And again, you can interpret this like a distance, right? What points are at most 2 units away from the origin? Okay, so if we think of in the number line, if this is 2 now, equal to, that will include 2, right? Because 2 is less than or equal to 2, but it also includes all of these values, right? All of these values are less than 2, right? Now, on the other end, though, remember absolute value, if we think of it as a distance, if I plug in -2, right, absolute value of -2 is 2. 2 is in fact less than or equal to 2, so that is also included. All right, and something like -1/2, right? The absolute value will give me just the value, which would be 1/2, and that is in fact less than 2. So it also includes all of these right here. All right, so we have this interval where every single number in this interval is going to satisfy this inequality. Right? Now, in terms of writing an inequality, right, we could say, all right, so I know the interval is from -2 to 2. Right? Now, I can write an interval like this in what is called a 3-part inequality, right, where x is bounded on top by 2, so it's less than or equal to 2, and then below it's greater than or equal to -2. So I can rewrite this absolute value to look something like this, right, as a 3-part inequality, right, without the absolute value, right, because that'll be helpful when we want to solve equations for x. All right, that is the approach that I'm going to take. Now, for this greater than part, let's take a look at what happens here. Let's say the absolute value of x greater than or equal to, let's say, 3. All right, and actually this one, let's do strictly greater than. Now, if we think of this in terms of distance, right, we're looking at from our origin, what values are more than 3 units away from x? Right, so you could say, all right, this is 1, 2, 3, 1, 2, 3. All right, now in this case, 3 doesn't work, right? Because 3 absolute value is not greater than 3. But any value to the right up here of +3, let's say 4, that will work, right? And 5, 6, etc. So that will work. So it looks something like this, right? But also on the other end, again, plug in -3, absolute value of -3 is 3. That doesn't work, right? But -3 is not greater than 3. But once we go past this on the left, like -4, absolute value of -4 is 4, and that is in fact greater than 3. So this value is included. And in fact, all of these values here to the left of -3 will satisfy that inequality. Right? All these points, again, distance, no sign is associated with it. It's simply the value of the number, right? We drop the negative. Okay, so seeing this, we could say, all right, I can rewrite this. All right, now this is not a nice 3-part inequality, right? There's no way I can solve x is not between two values, right? It's either bigger than 3 or less than -3. Right? So it's one of two possibilities, right? To rewrite this, we could say x is less than -3, or x, and I'll write that or, x is greater than 3. All right. So that's the approach we're going to take to kind of drop the absolute values and be able to work with our inequalities that are a little more involved than simply an x inside the absolute value, but have another expression here. All right. Now, in terms of interval notation, right, it's unbounded here on the left, so it goes from -infinity up to and not including 3. And then there's this gap, so none of these numbers are included here, but then it picks up here. So I use this big U, which is called union. So this together in union with 3, the lower bound, right, not inclusive of 3, and then it's unbounded here up top to infinity. All right. Okay, so that's how we're going to approach these problems. All right. So let's take a look at, let's say for this example, let's say I want to solve absolute value of x minus 2 is greater than 10. Okay, so greater than, that's one that I just finished doing here. So I'm going to drop the absolute value, right? I can't treat this as a linear inequality just yet because of the absolute value. So what I'll do is I'll say, all right, I'll drop this and then I'll switch around the sign, which is what I did here. So it'll be less than -10. And then or x minus 2 is greater than 10. Right, so one of them involves flipping the inequality, making it a negative, and the other one just dropping the inequality symbol altogether without changing anything. All right, so now we add 2 to both sides, and we get x is less than -8. Add 2 to both sides for this part, and we get x is greater than 12. All right. Again, this is an or. So now in terms of my interval notation, less than means we have something that looks like this, from -infinity to -8. Union, right, there's a break till we get to 12 up to infinity. Okay, so now here, let's do one more example here. All right, so for this example, I want to solve the absolute value of 3/4 x minus 5 less than or equal to 7. All right. Okay, so this is one of those less than ones. So we know that when we have something that is less than or equal to, right, we have absolute value less than some value. We can rewrite this without the absolute value as a 3-part inequality. Right, that looks something like this. Right, this is the middle part, and then the 2 parts are out here, and the one on the right is going to be +7. The one on the left is going to be -7. And we're essentially doing the same thing that we're solving 2 linear inequalities, but we just do them simultaneously, right? As opposed to the or one that we had previously, right? We have more of an and, right? We do them together. All right. So here, before we would add 5 to both sides, but now there's 3 sides, so we just add 5 to the 3 sides. Okay, and then here this becomes -2. All right, and then from here we multiply by 3/4. Oh, excuse me. We want to reduce this to 1, so we multiply by its reciprocal, in this case being 4/3. Okay, we see this reduces to 1. Over here we get, I can reduce here, 4 times 4 is 16. here. I can't reduce here. Right, so we get negative 8, excuse me, over 3. Okay. Just double checking my work here. All right, and then now, in terms of my interval notation, it'll look something like this, right? Inclusive of the inputs. All right, and that's how you solve these linear inequalities. Absolute value inequality, excuse me.